Alright, we start off with a physical examination of the subject. Take a look at the outside front here. It seems as though there's a vent, some sort of display. On this side, down here, we have some ports, one of which is open. Then on this side, we have a small annunciator-style buzzer or alarm. Let's open it up. Now you can see down over here, this is a pivot point that moves, and you can see over here that there's a little keyhole where you can shove this over after you loosen that screw. And we're in. So here's our little counter device, it looks like. Seems to be resettable with a dip switch on the back. Has 4 terminals, of which 3 are occupied. There's a ground lug here. These 3 things up over here are just little colored plastic hats for these 3 LEDs, which are up on standoffs off this main board. Then we have some sort of what looks like a sensor board, given what we know about this thing, which is that it is a gas detector of some sort. Power comes in down here, 24 volts AC. There's a ground lug on there, and then we have 2 24 volt relays right here. On the main board itself, you can see there's a full bridge rectifier and a fuse, and then a whole bunch of filter caps. That's to condition the power so that it's nice and flat, 24 volts DC, roughly. And luckily, we've lucked into having really nicely labeled PCBs here, printed circuit boards. So we can see 420 milliamp outputs over here in these stacked screw terminals. I don't know what J3 is, and it looks as though there was provision for some sort of other sensor on this board. Let's see if we can remove the board from this daughter board from the motherboard. Alright, so we have, that's a little bit different than what you normally see. These are 0.156 center connectors that are a little bit short, stubby, and those go into this header right here. So there's also an RS-232 interface. That's UART, which is the same way that we communicate with the Arduino. So it looks as though you've got that sensor subboard. This also has a provision for having a regular sensor on it, but it looks as though you can put in a card for whatever type of sensor you want. Alright, we've got more and different connectors up over here. There's a reset button and a test button. And then the relays are down over here. Currently they're disengaged from anything. There's nothing screwed into them. They're on a nice little piece of DIN rail in here. And so if we disconnect this cable, we'll disconnect the relays. Then we can disconnect this cable, which is our power coming from down over here, and we can take more of a look at our power subsystem. And our buzzers over here. These 3 wires then come out of a header that's called manufacturing test, or no, that looks like that's under the header. Anyway, let's see if we can get these out of here. I'm going to start off by cutting these little cable ties up here. Just be careful not to hit the wires. Alright, and now we're just going to unscrew these 4 Phillips head screws. Always hold on to the screws in case you need to put something back together. out, but we can't really reach it. So it will come up along with the board. Alright, board's loose. Now let's grab that screw. It doesn't say anything on top of that terminal over here, this junction. I'm just going to pull that out. And that is for our, I guess, parts per million or parts per thousand counter for whatever gas this is designed to test for. What we'll need to do is we'll need to look up part number 91AG over here and see whether or not that has any information on it online with regards to what this is actually detecting. You can also notice how they keep this flat on top of the motherboard, is that they've got this little standoff down here, and that sits against the motherboard itself. Now, as for the stuff that's down underneath, we've got a whole bank of full bridge rectifiers here, and I have no idea what that's all about. Then we have our little tie-ins over here for the buzzer or siren, and tie-ins for both relays, which seem to be in parallel with one. No, the grounds are in parallel, but the signals are separated. Alright. So, if we were to go down to the component level, we'd start tearing these things out, but I don't think we actually need to do that on this one. What we're going to start doing instead is looking up part numbers and see what else we can find out about this. One channel gas monitor dip switch settings. This will give us all of the settings that we can adjust on the motherboard right over here. And then there's also a diagram of the relay socket, so we know what's connected to what down in here. And if I pull on one of these relays, there's the socket. So this is actually channeled out right here quite nicely. It says alarm and warning, so we know that this one is for if it gets close to the level that we want to avoid, and the alarm is when it exceeds the level that we want to avoid. So from here on in, we're going to be taking down part numbers and just looking to see what can be garnered from our internet research on this. So here we're taking a look at the manual for the gas monitor, style 1A2. This is a 2-channel monitor, it turns out, but it only actually has one of the 2 channels populated. As we get further into the manual, we can see what we actually have to work with here. And you'll see that we don't actually have anything telling us what sensor this is in here. But if you take a look at the side of the sensor itself, you'll see that this is actually a carbon monoxide sensor, an electrochemical carbon monoxide sensor. We have the one with the bent legs on it that's soldered in place. And you'll see over here the sensitivity curve. And you'll notice that the units are actually in nanoamps per ppm. Now what that means for us is that we can't just take nanoamps and put that directly into an ADC. We're going to need to somehow condition this with a preamplifier. The ADCs then feed into an 8-bit microcontroller, this one from NXP, formerly from Philips. And the reason we're able to see which chip is the microcontroller is because first I found the RS-232 transceiver chip and then followed the traces back. So now we're going to go through the rest of what's needed for the lab report, which mainly includes figuring out how exactly this thing works, most of which I've already given you, and then the rest of it is actually beginning to draw a block diagram. Now I'm using OmniGraffle here on my Mac, but Visio or any of a number of other programs, including PowerPoint, could be used to make this block diagram. So here we have our carbon monoxide sensor, our CO sensor. Let's then make another block here. This is our preamplifier. In this case, we're going to be using an op-amp in a current follower mode. We're going to be converting from current to voltage, so we get that nanoamp signal into a form that an analog to digital converter, an ADC, can use. So here's the final block diagram and wiring diagram. We have a power supply down at the bottom, the carbon monoxide sensor, which gets power and then sends a signal out to the preamplifier, the analog to digital converter, which is a separate chip in this case, which also gets power from the power supply, and the microcontroller itself, which gets a signal from the analog to digital converter and power from the power supply. We also have the dip switch bank, which we saw on the board, and that's used to set which mode the microcontroller is in. That also takes care of setting our thresholds and all of the other information that we need to have, all of the other constants that we need to have to know when to trigger other things. Then when we go above a certain threshold, our buzzer will go off, our warning relay will trigger at some point, and then finally the alarm relay will trigger once we get up to a critical threshold of carbon monoxide. And that's it. That's all you really have to put together for this particular topic and this particular lab.